Today, we're diving into a global agricultural crisis that has been tearing across the world with absolutely devastating speed. But at the heart of this story isn't just the plague itself, but a really cool piece of technology that could fundamentally change how we fight it. A portable lab built for the front lines.
So let's start with a number, 6 million. Just let that sink in. That is the number of pigs that had to be culled in Vietnam alone by the end of 2019 because of one single relentless disease. And this wasn't some isolated thing, it was part of a massive wave that just swept across Asia, causing unbelievable losses.
You see, 6 million isn't just a statistic. It represents a massive hit to the economy, a huge threat to food security for millions of people. And the culprit behind all this has a name, African swine fever. It's a disease that, up until now, has always been one step ahead of us.
Okay, so let's get a really clear picture of the enemy here. African swine fever, or ASF as we'll call it, is a massive challenge for farmers and vets all over the world.
So what is it, exactly? Well, ASF is this super contagious virus that hits both domestic pigs and wild boars. It started in Africa, but since 2018, it has just exploded across Europe and Asia. And here is the absolute kicker. There's no effective vaccine, and there's no treatment. So control isn't just important, it is literally the only thing we can do.
And when we talk about control, the stakes just couldn't be any higher. The most aggressive strains of the ASF virus have a mortality rate of nearly 100%. Once a herd gets infected, it's pretty much over. We're talking total devastation.
So you've got no vaccine to prevent it, no medicine to cure it. What's left? Well, the entire battle against ASF really comes down to just one thing: speed. How fast can you get a diagnosis? Early detection and containment are the only tools in the toolbox.
But here's the big problem. You can't just look at a sick pig and go, yep, that's African swine fever. The symptoms, the clinical signs, they look almost identical to a bunch of other, way less catastrophic swine diseases. So that makes a fast, reliable diagnostic test absolutely essential. There's no other way to be sure.
For years, we've had to rely on lab-based testing. But these traditional methods, they're accurate, sure, but they have this critical weakness in a fast-moving outbreak. They're slow. They create this time lag, this window of opportunity where the virus can just keep on spreading.
Let's just break down the options, right? There's virus isolation, basically growing the virus in a lab. It's super accurate, but way, way too slow for an emergency. Then you've got serologic tests, which look for antibodies. They're faster, yeah, but they often completely miss the crucial early days of an infection. So that leaves real-time PCR. Now, this is the gold standard for accuracy in the lab, but it needs bulky, expensive equipment and highly skilled techs, basically chaining this powerful tool to a central lab, miles away from the actual farm.
You can see the delay just built right into the system. A sample gets taken on the farm, but then it has to be shipped off to some big central lab. It gets processed, analyzed, and only then is the result sent back. By the time that happens, days have passed. And in those precious days, a small, controllable outbreak can explode into an unstoppable epidemic.
And this is where the cool part comes in. This is where innovation steps up. What if you could take the power and accuracy of a sophisticated lab and put it directly into the hands of a vet, right there on the farm? Well, that's the whole promise of a new technology designed to slam that critical time gap shut. It's called insulated isothermal PCR, or iiPCR for short. Now that sounds pretty complex, but the idea behind it is actually super clever. Instead of slowly heating and cooling the entire sample over and over again, it uses natural convection, the way hot liquid rises and cool liquid sinks, to circulate the sample through different temperature zones all inside one tiny tube. It's just a much, much smarter way to do it.
Here's a great way to think about it. A regular oven has to heat the whole chamber, and that takes time. But a convection oven circulates hot air, which cooks everything way faster and more evenly. This iiPCR system does something kind of similar with a liquid sample, which dramatically speeds up the whole DNA copying process.
And the best part, the whole system is designed to be incredibly simple to use. You prepare a quick sample, pipette it into a preloaded cartridge, pop that cartridge into the portable device, and just hit start. That's it. The machine does everything else and gives you a clear positive or negative result. No PhD required.
And here is the real payoff. This is the game changer. The standard lab process takes over 4 hours plus all that transport time, which often stretches into days. This portable iiPCR system, it gives you a result in about an hour and a half right there on site. It literally transforms the response time from days into hours.
Okay, so it's fast. But is it any good? Is it accurate? I mean, that's the million-dollar question, right? A fast or wrong answer doesn't help anyone. So in one of the world's biggest hotspots for this disease, researchers decided to put this portable lab through the ultimate real-world test.
So this study went down in Vietnam, one of the countries that got hit the hardest by ASF. They took hundreds of real samples from pigs, lymph nodes, blood, spleen tissue, you name it, and they tested every single one using both the new portable iiPCR system and the established lab-based gold standard.
First up, sensitivity. Could the portable system detect even tiny amounts of the virus? And the answer was a resounding yes. It could find the virus in samples that were diluted up to 1 million times. That made it just as sensitive and in some cases even more sensitive than the official high-end lab test.
Okay, so it's sensitive. But does it give you the same answer as the gold standard? And look at this, overwhelmingly yes. Across hundreds and hundreds of samples, the results from the portable system and the big lab test had a greater than 97% agreement. That shows incredible reliability.
So the final report card was just outstanding. The test was super specific. It didn't get fooled by other common pig viruses. With near-perfect sensitivity and accuracy across the board, the results were crystal clear. This portable system wasn't just fast, it was also incredibly reliable.
So the technology works. It's proven. What does this actually mean for the future of controlling not just ASF, but all kinds of other devastating animal diseases?
Well, the impact is frankly profound. You're putting the power of a diagnostic lab directly on the farm, in the field. Vets can identify infected herds in just a couple of hours, not a couple of days. This means they can take immediate action, quarantine, biosecurity, culling, which drastically shrinks the window the virus has to spread. It has the potential to be a complete game changer for how entire countries manage disease control.
And this brings us to one last, really powerful question. This same core technology has already been adapted for human diseases like Zika, dengue, and SARS-CoV-2. So if we can bring rapid, reliable diagnostics to a farm to stop an animal plague in its tracks, just think, what could this same approach mean for stopping the next human pandemic before it even gets started?